While everyone watches a ghost from deep space, something else is arriving much, much closer. For months, we've been mesmerized by a stranger from the outer dark 3i. Atlas its story, stitched from long exposures and speculation. Its distance a comfort dressed as wonder, but beneath that dream, another clock is running. Its hands aren't painted on the far edge of the solar system. They sweep under our sky. On the 13th of April 2029, an asteroid with a myth-carved name will skim past Earth closer than many of the machines we launched to look back at it. The quiet truth is simple. The nearer risk isn't the interstellar visitor. It's 99942 Apophis, threading a path through the architecture of our daily lives. We keep staring outward for the extraordinary, while the extraordinary is preparing to pass right overhead. Imagine Earth as a lantern wrapped in rings of light, low orbits buzzing with weather eyes and mapping cameras, mid-altitudes where navigation time whispers its millisecond cadence, the high geostationary ring, beads fixed over the equator. Now imagine a 300+ meter worldlet, bright enough for the naked eye at dusk, slipping inside that high ring tens of thousands of kilometers from your breath, close enough to track against the stars without a telescope. Well, raise our phones. Well, cheer. It will trend. And after that communal gasp, many will move on. Headlines will file the event under spectacle and close the tab. Stories don't end at the exhale. They begin. What changes when a rock meets a planet not by impact, but by intimacy? Apophis isn't a villain, and this isn't a doomsday monologue. It's a lesson in proximity. Distance and statistics have trained us to think in averages. Low risk, no threat this century. Phrases tuned to steady public pulse and budget lines. But anyone who has watched a pool shot knows the treachery of small angles over long tables. A cue ball leaves the tip with the faintest tilt and ends up nowhere you expected. Space is a very long table. Tiny forces, not dramatic, not loud, but persistent, decide everything. Nothing turns a probably into a let's check again, like a close pass. We could keep the conversation far away with catalogue numbers, long arcs, and interstellar mystique. But this film is about contact without touching, tides that knead, heat that whispers, spin that shifts by degrees too small for headlines. The danger is not one frame of catastrophe. It's a reel of subtle edits, margins shaved here, a parameter nudged there, accumulating into a different third act years later. That's why this story, unlike the clean comfort of a press release, refuses to lock. It lives in the grey between safe and certain. If it sounds like an invitation to panic, it isn't. Panic is useless here. What works is light, silence, memory, breath, the four motifs that will guide us. Light, not just brightness, but the information it carries about texture, spin, and heat. Silence, not absence, but attention listening for motion where noise pretends to be certainty. Memory, before, after baselines, the discipline of recording how things were, so change can't gaslight us. Breath, the pacing of a species that plans inhale to look, exhale to measure, repeat. These motifs will return like stars you learn to recognize each time the camera tilts. They're the scaffolding for calm urgency, how we proceed when the line between spectacle and signal might hide in the second decimal place of a parameter your neighbor has never heard of. There's another misdirection at work, an emotional one. Interstellar visitors feel philosophical. They tempt the poetic questions. Where did it come from? Message or accident? We project meaning into the void and feel larger for having asked. Apophis isn't philosophical. It's procedural. It forces us to audit the measurement plan, uplink windows, funding cycle, and backup redundancy. It demands we honor boring heroism. Radar schedules, telescope cues, error bars that shrink because someone kept chasing them down. Wonder keeps you watching the sky. Responsibility keeps the sky from surprising you. Here is what the headlines flatten. When a mass that size comes that close, gravity speaks. Earth's pull doesn't just bend a path, it can tug at seams we can't see. If Apophis is loosely bound grains and boulders, held by weak bonds, the pass isn't just a flyby. It's a stress test. Slopes near their limits may relax. Dust may migrate. Fresh surface may wake to sunlight. It hasn't tasted in ages. None of this looks cinematic from afar. All of it can change the quiet math steering the orbit over the years. And then there's heat, the most patient sculptor we know. Day warms, night cools, and that thermal breath becomes a soft engine. The kind of force you'd ignore in a hallway too small to matter until you realize it never clocks out. Change the spin a little, the roughness a little, the speed. Different patches store and release warmth a little, and that soft engine starts aiming differently by a fraction of a fraction. 10 years later, that fraction is geography. This isn't a call to fear. It's an invitation to measurement. The outcome we want nothing to see here, carry on, isn't granted. It's earned. Earned by telescopes with the right filters on the right nights. Earned by spacecraft that arrive while the encounter is still fresh. Earned by teams that don't confuse absence of evidence with evidence of absence. Ahead, you'll hear numbers, altitudes and angles, periods and thermal constants. You'll hear about small forces, fragile spins, resonances that act like recurring appointments on a calendar we didn't set. You'll meet unglamorous heroes, radar dishes humming past midnight, flight software that refuses to fail, budget votes that arrive before it's fashionable, and sometimes, when the science allows and the poetry helps, we'll widen the frame for a quieter truth. Vigilance isn't fear. It's care. The world loves tidy endings. We're going to resist one. Each section will land softly, not with closure, but with composure. Each time, the last lines will leave the door unlatched, because reality rarely slams shut. That isn't indecision. It's fidelity to how knowledge grows. By edges, not proclamations. In April 2029, crowds will look up and see a bright dot sliding past like a polite comet that forgot its veil. We will look and see a question about spin, heat, and patience that only precision can answer. And that answer begins with distance, not drama. Next, the numbers. You can feel how close is close when it's nearer than the sky we built ourselves. 30,000 kilometers. Closer than some of the satellites we depend on every hour of every day. Say the number slowly and let your eyes stay open. 30,000 kilometers. If you could stack Earth's tallest thunderstorms end to end all the way through the sky, you'd need thousands of them to reach the path Apophis will carve. It won't be a distant abstraction on a news crawl. It will be a moving point of light, bright enough to find in the evening, with nothing but your hands for a tripod. Our machines will be looking down at us. This rock will sweep between some of those machines and the edge of night. Picture the sky as a layered city. Low orbits whir like busy streets, weather sentinels, Earth imagers, human stations crossing from shadow to dawn. Above that, the middle ring where navigation keeps time and distance honest. Pulses of precision bouncing between high antennae and ocean, truck, pocket, and higher still, the quiet boulevard of geostationary watchers, fixed over the equator like lanterns that never drift. Apophis will thread this city, not a wrecking ball, not a rumour, an object with mass, momentum, and a schedule, a body older than language, entering a space we built within a single human lifetime. You won't feel the wind shift. There is no wind, but the world will feel slightly different that night, as if the atmosphere itself were listening. Amateur clubs will roll out Dobsonians and lawn chairs. Kids will chase a white dot with their smartphones. Someone in a small town will aim a pair of binoculars so carefully you'd think they were dialing a safe. For those few minutes, the distances we learn in school astronomical unit, light year collapse into something you can point at and say, there. This is what near means when the subject is a worldlet and the verb is passing. Near means radar beams leaving dishes and coming back so quickly that the operators barely finish their sip of coffee. Near means light curves that breathe with the object's heartbeat. Each dip and rise a hint about shape and spin. Near means that sunshine stops being a postcard and becomes a tool. Heat in, heat out. A thermal exhale with a direction we can measure. Near turns numbers into feelings. You count seconds between a star and the bright dot and sense. In your ribcage, that space is not empty. It is precise. The camera pulls in closer. We stack the layers in front of you. Airplanes down low. Then the thin parade of low Earth orbit. Then the navigation ring where timing rules. And far beyond, the geostationary line. You see the gap just a few thousand kilometers between that highest ring and Apophis path. Just enough room for a mistake if the universe were careless. Just enough room for wonder if we are not. Hold the frame. Breathe. In that slender slice of altitude live our forecasts, our emergency calls, our storms mapped before they break cities, our television feeds, and the monotonous metronome that gets ships into harbours and patients into operating rooms on time. We forget, because forgetting is easy, that civilization is nested in orbits. We forget, until a stone from elsewhere threads the nest. And yet, the feeling is not terror, it is awe with edges, like standing at the rail of a canyon, and knowing the view is safe, while also knowing that safety took planning. The railing, the signs, the choice to show up in daylight, the common sense to stay a step back. Awe has a maintenance schedule. So does Earth. What does 30,000 kilometers sound like? To a ground-based radar, it's the echo that returns before a sentence ends. To a telescope, it's the difference between a faint smear and a clean, glittering point that slides almost rudely across the field of view. To the human eye, it's the shock of recognition when you realize a thing that something ancient is not a diagram. It is above your roofline, now, moving, now, writing its small line through your sky, now. If you listen for it, you can hear the city check its mirrors. Satellite operators will rehearse contingency plans for crosstalk and glare. Observatories will coordinate handoffs like baton exchanges so the dataset stays unbroken as night rolls from desert to island to mountain. In the quiet rooms, people will argue over exposure times and thermal models, and someone will keep repeating the same sentence in different tones until it calms the room. This is the best chance we will ever have. Because it is. Because distance is the enemy of certainty. Because nothing shrinks an error bar like a close pass. There's a moment, right after the first exhale of wonder, when the mind flips. You see the path inside the high ring, and you think of all the sentences you've heard for years, no risk for a century. We've modelled it. We're confident, and you feel a tiny grit of doubt under your tongue. Not a distrust of the people or the math, but of what math becomes when we forget how assumptions hide in its pockets. Confidence is a tool. It should be checked out and returned, not carried like a family heirloom. The closer you get, the louder the small things matter. A surface that slumps a little under Earth's tug, exposing fresher regolith. A spin that shifts by a sliver, changing when the dayside heat chooses to leave. Roughness here and smoothness there, and a night that runs a few minutes longer or shorter across a facet the size of a stadium. You can't see those differences at the eyepiece, but the orbit can feel them over years, the way a river remembers every stone it brushes while pretending to forget. Another breath. Think of how we mark our lives by flybys, a comet that flared in your childhood, a lunar eclipse you watched with a friend who is now a story you tell. This pass will belong to millions. It will be the night people learned the scale of their home because something large moved politely through it. And in that politeness is a second lesson. The universe does not owe us drama to change our minds. A near miss can be a seminar. A seminar can be a turning point. So we will count. We will time. We will compare. We will write down what light did when it struck this surface at this angle on this date so that memory becomes a tool, not a mood. We will file the measurements where we can find them again, and we will argue over them until the argument leaves a smaller remainder. We will let silence do its work, the kind of quiet that isn't empty. It's listening, and we will keep listening after the dot has faded, because the work does not end when applause would. At street level, it will look simple. A bright point, then not. On dashboards and consoles, and in the cool rooms with the hum, it will become a lattice of facts. Paths crossed, reflections measured, echoes timed, a frame by frame of a gravity lesson that will not repeat. The awe is the invitation, the shock is the clarity. It came this close, which means the model has to be that good. And after the cheers, after the posts, and the sky selfies and the bars, telling stories about the night the star moved sideways, a question will linger like an afterimage. If our certainty about the next 100 years is printed on the thin paper of assumptions, spin states we inferred, surfaces we guessed at, heat behaviors we approximated, what does this pass erase, and what does it underline? If no threat is still true after the best look we'll ever get, good. But let us say it then because we measured, not because we memorized. 30,000 kilometers, closer than comfort pretends, close enough to turn our instruments into mirrors and let us see not just a rock, but our habits. Close enough to remind us that awe is not the opposite of precision, it is the reason for it. Next, we pivot from the view to the promise. When reassurance speaks in headlines, what exactly is it promising, and what small forces are left out of the frame? NASA says, no threat for 100 years. The math says, probably. That sentence isn't conspiracy bait. It's a translation problem. No threat is public language comfort shaped into a headline. Probably is scientific language confidence, bounded by assumptions. Between those two dialects lies the real story. Models are maps, and every map hides the mountains it hasn't been asked to draw yet. Start with how an orbit is made. You measure where a thing is, when it is there, and how fast it's going. You do this across nights, across years, with optics that read starlight like a ruler and radar that times echoes like a drum. Then, you fit a curve through the data, a path under gravity that explains all those points. The fit is never perfect. The universe never grants perfect. So you embrace imperfection honestly. Attach an error ellipse, a covariance matrix, a cloud of nearby futures that the object could take if your initial guess is nudged by a hair. Then you push that cloud forward in time. Most days, this is enough. Gravity is generous that way. It tolerates our ignorance and still gives orbits that hold together. We say confidence and mean. The cloud stays far from our planet for as long as we care to compute. But confidence is a living thing, and the food it eats is assumptions. We assume the object's mass distribution doesn't shift. We assume the surface won't change in a way that changes heat. We assume the spin behaves well enough that yesterday's tiny thermal push looks like tomorrow's tiny thermal push. We assume our observations sample the truth fairly, that there weren't silent biases hiding in a cloudy night or a calibration frame. The model, in other words, is only as good as the world it believes in. There's a line between public reassurance and professional humility that always looks thinner in hindsight. The reassurance says, decades are safe. The humility says, decades are extrapolations. One is a sentence, the other is a practice. A practice that checks its pockets for unexamined priors. The typical asteroid assumptions we inherit because we must start somewhere. The default thermal properties, the default density, the default cohesion, the default roughness that turn an empty spreadsheet into a solvable one. Honest modelers will tell you what they told themselves first. Here's where we guessed. Here's where the guess probably doesn't matter. And here's where the guess could echo. If those guesses change after April 2029, the cloud moves. This isn't because anyone was sloppy. It's because reality edits itself when gravity and sunlight get to work up close. Think of a chess engine pre-computing lines. All it takes is one unexpected pawn move for the tree to blossom differently a dozen turns later. Our pawn moves are subtle, a millimeter of dust resettled, a spin axis precessing by a few tenths, a boulder's shadow shrinking a little at local noon, so an afternoon heat plume leaves at a new angle. The math that says probably respects those kinds of things, because probability is a way of saying, we know which parts of our ignorance are quiet and which might be loud. Public statements must be simple. Space does not owe us simplicity. Look closer at the words that make certainty sound sturdier than it is. Cleared from the risk table. Technically true and a relief. But clearance is a snapshot honor, not sainthood. It means, under current data and current assumptions, this path misses us by enough that we can focus on nearer problems. It does not mean nothing you could learn later would change our minds. The risk table is not a tombstone, it's a whiteboard. Chalk wipes. New chalk appears. Look closer at 100 years. It's not a prophecy, it's a horizon. We compute until rounding error and accumulated uncertainty make the picture useless. We stop where responsible people stop. We communicate in tidy windows because human attention needs windows. But the asteroid does not read our windows. It reads physics. It reads the small, persistent forces we didn't include because they were smaller than the noise last time we checked. Ask anyone who lives in models for a living, and they'll show you two kinds of uncertainty. Aleatory, irreducible randomness, like the roll of a die. Epistemic, ignorance you can shrink with better knowledge. Most of what scares us about orbits is epistemic, not fate information. We can weigh better, we can see finer, we can map the day-night thermal breath with more fidelity. We can discover that the rubble pile is tighter than we assumed, or looser in places, or that its exterior is smoother than the averages suggest. Each of those discoveries is a tweak in a parameter that touches the future more than your intuition expects. But they said no threat. They did, and they should, based on the evidence in hand. The phrase is a shield against panic. It is not armor against the need to keep measuring. When a spokesperson has to speak to millions, the sentence must fit in one breath. When a navigator plots a close pass, the sentence is a notebook of caveats. No threat, and keep watching are not opposites. They are partners. One calms, the other keeps the work honest. Remember also how models get trained on their own past. We build pipelines that behave beautifully on known asteroids, because known asteroids teach them what normal looks like. Then a body arrives that is normal until a force you can't yet see wakes up and starts signing its name at the second decimal place. The pipeline smiles and says, "Still normal." The sky smiles back and says, "Check again." Not because the pipeline is broken, but because normal has edges you only notice when you stand right against them. Which is why April 2029 matters so much. It is not only a spectacle, not only a national night of pointing up, it is a calibration point, a chance to replace priors with measurements. Radar that turns shape models from guesswork into geometry. Light curves that turn from suggestive to insistent. Thermal data that says, with fewer excuses, how the soft engine breathes. After that, we will have earned a different sentence, perhaps an even calmer one. But earned is the operative word. Until then, hold your skepticism like a compass, not a sword. Don't slash headlines for being simple. We need simple. Use them to point you toward the deeper notes. What inputs fed the model? What was assumed about rotation and surface? How sensitive are the long-term returns to small changes in those inputs? What happens to the no-threat chorus if we learn that sunlight pushes a little harder at dusk than at dawn because a patch of terrain lost its dust? None of this is doom. All of it is duty. The promise we can make without lying is modest and strong. We will keep shrinking the ignorance that matters. We will not confuse clarity today with certainty forever. We will treat models as instruments and update them when the music changes. And when we say no threat, we will mean it in the only honest way, no threat given what we now know and are still learning. Next, we stop talking in generalities and name the first quiet culprit, the smallest force with the longest reach, the gentle engine that can move mountains if you give it time. Sunlight pushes this rock, just enough, not like a sail cracking in a storm, not like a shove you could feel in your palm. The push we're talking about is quieter than dust landing on dust. It comes from warmth, daylight absorbed, and then re-emitted as infrared, photons leaving the surface with the faint insistence of breath on glass. Each photon carries momentum. Each departure is a nudge. Add up uncountable nudges across uncountable sunrises, and you get a real result. The orbit moves. This is the Yarkovsky effect, and it hides in plain light. A stone turns. One side faces the sun and heats. The spin carries that warmth into the afternoon, where it escapes slightly later, aimed slightly off from noon. Because those infrared photons leave in a preferred direction, they provide a tiny recoil. Day after day, the same bias repeats. And what gravity writes as a closed curve, heat edits as a long, slow drift. Not a dramatic detour, a steady migration of the semi-major axis, millimeter by millimeter, that, over years, becomes kilometers, over decades becomes geography. What makes this whisper powerful is that it remembers. Thermal inertia gives sunlight a lag, roughness traps and re-radiates. Concavities self-heat. Shadow and slope choreograph a pattern of little pushes that align with the spin like footfalls along a trail. If the asteroid rotates prograde, the diurnal Yarkovsky effect tends to push outward. If retrograde, inward. Change the spin axis and you can change the sign. Switch the texture and you can change the magnitude. It's a soft engine with delicate controls, tuned by details we often infer instead of know. Hold one in your mind, a boulder the size of a house, perched on a slope. Morning warms its face, and afternoon exhales from its flanks. The photons leaving at 3 p.m. aren't the same as the photons leaving at noon. They point a little differently. Multiply that by every grain, every facet, every little canyon, and you begin to feel how non-gravitational acceleration stops sounding academic and starts sounding like weather, a climate of light, sculpting motion over time. This is where models grow fragile, where good enough inputs turn out to be almost good. We can know the orbit to many decimals and still watch those decimals erode under daylight's patience. We can fit a beautiful curve through radar points and optical positions and still discover, years later, that the curve has drifted because afternoon heat never missed a shift. A change so small it won't impress. A headline can still walk an asteroid into or away from a keyhole corridor it would otherwise have ignored. You can hear the rhythm in the vocabulary. Thermal drift, recoil, diurnal and seasonal components, albedo, thermal inertia, effective roughness, self-heating, beaming. Each term is an instrument. Together they make a pulse you can't dance to, but you must measure. And you measure by learning to read light as a verb. How quickly does the surface take on warmth in? How reluctantly does it let warmth go? Is the exterior a blanket of fine regolith that smooths temperature swings? Or a quilt of rocks that makes the day exhale in gusts? Rotation sits at the heart of the answer, because rotation tells heat where afternoon lives. Tilt the spin axis, and you relocate afternoon to a new latitude. Speed up the spin, and you shorten the hour hand. Slow it, and you lengthen it. Some bodies tumble, trading order for a kind of thermal noise that models hate. Afternoon smears into a wobble, and the soft engine coughs. Others keep a disciplined roll, letting the engine hum in one direction long enough to matter. We often don't know which story is true until a close pass gives us light curves loud enough to decipher. And the engine is not alone. There's a cousin with a more mischievous personality. Yarp, the torque that sunlight can exert on irregular shapes, spinning them up or down over time. Yarp changes rotation. Rotation changes the Yarkovsky push. The push changes the orbit, and the new orbit changes the sunlight geometry again. A feedback loop, gentle and slow, but not content to sit still. Add Earth's tidal hand to the mix during a flyby slopes relaxing, surface migrating, and you can reset the settings on both rotation and thermal response in a single afternoon. This is why a sentence like "no threat for 100 years" has to breathe. It must inhale the assumptions and exhale the caveats, because heat makes promises on its own schedule. Even if nothing dramatic happens in 2029, no sheds of dust, no boulder strolls, minute changes to surface roughness or spin can retune the engine just enough to nudge the path differently by the time returns matter. That nudge will hide in the decimals for a while, then show up one day as a timing difference in a radar echo, an arrival a bit early, a departure a bit late. Think of a river again. The current looks steady from the bank, but place a leaf and watch which eddies claim it. A small protrusion on the riverbed, one you can't see, guides the leaf to a different bend. Sunlight is the river here. Afternoon, the protrusion, the asteroid, the leaf. We map the current as best we can. Then we check if the leaf went where the map said it would. If it didn't, we redraw the river, not because the river lied, but because we finally noticed the stones. There is quiet awe in this. We are tiny animals on a wet rock, learning to hear the murmur of photons slipping off another rock and letting that murmur steer our decisions. We learn to translate glints and glows into forces, into accelerations too small for a human muscle to feel yet large enough for a world to heed across time. Light, silence, memory, breath. Light to push and reveal, silence to attend without panic, memory to compare before and after, breath to keep the cadence as we refine. When the pass comes, we will try to trap the engine in numbers. Thermal infrared will sketch temperature maps. Radar will constrain shape. Photometry will take the pulse of the spin. Polarization may hint at texture. Occultations will slice silhouettes against starlight. Every dataset is a hand on a dial that turns a vague tiny push exists into the tiny push points here with this strength. Each dial we set by measurement makes the model less fragile and our reassurance more earned. None of this asks you to be afraid. It asks you to respect what builds up. The cliff does not fall because of a single raindrop. The valley does not form in a single storm. The orbit is the same way. Sunlight, which grows our food and warms our skin, also writes slow notes in the margins of celestial mechanics. Learn to read those notes, and you turn a show into a seminar into foresight. We have met the tiniest push. Next, we face the part that makes it unpredictable, how the rock really spins when no one is watching, and how a hidden wobble can turn yesterday's nudge into tomorrow's surprise. We're not even sure how it spins. That admission carries more weight than it sounds. Rotation isn't flavor text in an asteroid's profile. It's the steering wheel for the tiniest push we just met. Spin decides where afternoon lives, how heat leaves, which way photons nudge. If we misread that steering, the path we forecast becomes a polite fiction. Start with the simplest picture. A rigid body, neatly rotating around a single principal axis like a well-balanced top. In that world, the light curve, the rise and fall of brightness, repeats like a heartbeat. The peaks line up with the same facets facing us again. Periods stay stable. models relax, but really small bodies are rarely that tidy. They're irregular, lumpy, porous, stitched together from rubble. Their brightest face isn't a face. It's a moment when shadow and slope happen to agree. Then there's the uncomfortable possibility that the spin is not single at all. Tumbling non-principal axis rotation turns rhythm into jazz. Angular momentum is conserved, yes, but the mass distribution forces the body to precess and wobble, smearing afternoon across latitudes like a dragging brush. The light curve stops repeating cleanly. The apparent period changes with viewing geometry. The same object can look stable in one season and mischievous in the next, and your best fit period from last year becomes a shrug. Photometry tries to help. You measure brightness over nights and weeks and look for repeats, then stack solutions into a model of shape and spin. But the inversion problem is cruel. Many different shapes and spin states can produce similar light curves, especially when the phase angles are limited or the data are noisy. Add a flyby that changes the geometry quickly, and the curve you thought you'd pinned down begins to slide in your hands. Ambiguity is not a footnote, it's the headline. We ask radar to step in. Range and Doppler spread sketch silhouettes and rotation rates with welcome authority. Surfaces crawl through frequency space. Echoes broaden with spin. Bright tongues hint at boulders and concavities. But radar time is precious and geometry dependent. You get snapshots, not a diary. Stitching those snapshots into a coherent rotational story is possible and transformative, but it demands coverage that missions and budgets don't always allow. Meanwhile, the soft engine of sunlight continues to care about details. A body with a steady spin funnels the Yarkovsky push in one general direction. A body that tumbles averages that push into something smaller, stranger, or even opposite over time. A small change in obliquity can flip the sign of the drift. A tiny shift in period fractions of a second over months can retime the thermal exhale enough to matter over years. The difference hides in decimals that headlines won't print but the orbit can feel. Technical unease lives in those decimals. Consider a surface that isn't uniform. Coarse rock here, fine dust there. The coarse patch heats fast and dumps heat fast. The fine patch lags like a slow lung. As the body rolls, the orchestra of micro-afternoons plays a pattern that only a correct spin model can interpret. If we mistake a wobble for a steady roll, we misassign which patch was exhaling when. The computed recoil points a few degrees off. That error compounds gently, then not gently. Light, silence, memory, breath return to the motifs for balance. Light. Read not just intensity, but timing and polarization, which can whisper about texture and alignment. Silence. Accept that gaps in coverage are not emptiness. They are prompts to listen closer when geometry improves. Memory. Compare carefully before 2029. During, after, so that even if the spin state is slippery, the change is legible. Breath. Keep cadence. Don't rush a fit that punishes haste later. We also have to watch for the sky's own tricks. Viewing geometry shifts the apparent period as Earth moves. Solar phase angles flatten or amplify peaks. Shadows that read as shape can actually be time of day effects masquerading as rock. Even the instruments, habits, tracking errors, calibration quirks can smear a curve into a ghost of itself. The cure is coordination. Independent teams, different telescopes, overlapping windows that let solutions converge not by charisma, but by consistency. Another subtle actor is waiting in the wings. Yorp, the torque sunlight exerts on irregular shapes. Over months and years, it can spin a small body up or down, nudging the period toward instability or calm. A shape that seemed content can drift toward a threshold where loose material migrates. A tumbling state can evolve toward a principal axis or away from it. Yorp is the slow hand on the spin dial, and the flyby is a chance to catch the hand in motion. All of this would be academic if the past were far. It isn't. Proximity turns academic into actionable. During the approach and departure, we will watch the light curve change night by night as geometry whips around. We will time radar echoes that slice rotation from uncertainty. We will try to disentangle tumbling from simple precession and ask the question that matters most. Where does afternoon live on this body, really? There's quite a drama in the answer, because the afternoon is the address where the tiny push picks up its mail. If we cannot fix the spin state with confidence, the model's long-term forecast becomes conditional. If prograde, drift outward by this much. If retrograde, inward by that much. If tumbling, average to almost zero, or to a surprising residual depending on texture. Not a single path, but a forked river with labelled channels. That's honest and workable if we get the labels right. It becomes fragile when we pretend we have one channel and speak as if the others never existed. We're not after theatrics. We want the choreography. Which angles lead the heat by how much? Which facets command the exhale? Where does the axis point after Earth's tide has its say? The questions sound small. The consequences are not. A half-degree change in obliquity can be the difference between a keyhole corridor being grazed or ignored decades later. A fractional shift in period can retime seasonal heating just enough to move a return by weeks. Then, by the width of our comfort, listen closely to the unease. It's not fear. It's respect. Respect for angular momentum that refuses simplification. Respect for rubble that behaves like a fluid when gravity whispers. Respect for instruments that confess their limits. Respect for the fact that we're not even sure how it spins is not an excuse, it's a plan to find out. And that leads us naturally to the next question. If rotation is the steering wheel for the tiniest push, what happens when Earth, by simply being near, reaches out with its gravity and gives that wheel a subtle twist? Earth's pull could knead Apophis like dough, not enough to tear it apart in some cinematic spray, but enough to make a rubble pile remember that it is, in fact, rubble. Many asteroids in Apophis size class are not monoliths. They're agglomerations, grains to boulders locked by weak gravity. A little cohesion, and the long patience of time, bring such a body through a deep gravitational well, and stress lines wake up. Slopes that held their breath for eons finally exhale. Tidal stress is the quiet villain here. As Apophis approaches, Earth's gravity pulls a little harder on the near side than the far side, a gradient that flexes the interior and tilts the balance on surface slopes. On a rigid world, the shell resists and springs back. On a rubble pile, the shell flows, not like water, but like a dune under a stiffening wind. Grains unlock, creep, and then beyond a threshold slip. The difference between staying put and slumping can be a fraction of a degree in local slope, or a whisper of extra acceleration across a few minutes near closest approach. Material doesn't need to avalanche grandly to matter. A veneer of fine regolith migrating downhill can expose fresher, rockier patches. A few decimeters of dust relocation can alter roughness enough to change how heat is stored and released. Cohesion, the faint electrostatic, and van der Waals forces that help grains cling can be overcome when tidal acceleration, plus spin, plus local vibration, all push the same way. What looked calm becomes a slow-motion rearrangement, invisible from a living room balcony, but legible in the way light curves breathe afterward. The body horror, if you can call it that, comes from imagining the inside. Void pockets are shifting shape. Contact points between boulders are tightening or loosening, transmitting little jolts that rattle talus on a slope half a kilometer away. Microfractures speak to one another across the hours. A chorus too low for human ears, but not for instruments. It's a creature made of parts that don't know each other's names, learning them briefly as Earth leans in, then forgetting again on the way out. We don't have to guess wildly. We've watched tidal encounters bruise small bodies before, and we've seen their skin change. Some show boulder tracks where nothing rolled in, living memory, then suddenly did. Others brighten or darken subtly as fresh material is revealed. In every case, the lesson repeats. You don't need a crack to change a worldlet. You need a nudge to a pile that's already at the edge of moving. Now, connect this to the soft engine of sunlight. If resurfacing exposes rockier, lower porosity patches, thermal inertia rises, afternoons lengthen, the timing of the infrared exhale shifts. If dust blankets thicken in places, inertia falls, afternoons quicken, the exhale shifts differently. Change the roughness field, and you change the beaming of thermal photons. Concavities that once re-radiated inward now open to space, or vice versa. Each small redecoration of the skin is a twist of the dial on the Yarkovsky push. The push remains tiny, the consequences do not. Even structure can be tested. If Apophis harbors a concealed contact binary two lobes, kissing under gravities, compromised tides can adjust that embrace. A few centimeters of separation or compression alter the mass distribution, which changes the moment of inertia, which perturbs spin state, which retimes afternoon, which retunes the push. The chain sounds baroque until you realize it's just cause and effect linked by patience. We are used to thinking of forces as events. In small bodies, they're habits. This is why even 1% matters. 1% is not a headline, it's a hinge. A 1% change in surface thermal properties, averaged over a rotation and integrated over seasons, can bias the tiny push enough that it returns a few decades outshift by thousands of kilometers. A 1% reallocation of mass can change the precession rate. A 1% adjustment in obliquity can flip the sign on long-term drift. 1% is how the future notices the present. Listen to the physics with your eyes. Imagine a stadium-sized boulder resting on a slope at the threshold of movement. Earth sweeps by, raising microtides through the body. The slope angle effectively increases for minutes. Grains at the base lose a little grip. The boulder settles a few centimeters, rotating just enough to change the shadow it casts at local noon. That shadow used to shield a patch of dust that released heat at dusk. Now, with more light, that patch exhales earlier. The recoil from those evening photons pivots by a degree that a headline will ignore and an orbit will honor for years. There's also a thermal tidal handshake to consider. Tidal flexing can modestly warm interiors and disturb fine grains, altering how quickly surfaces equilibrate with sunlight afterward. That, in turn, changes the immediate post-encounter Yarkovsky behavior before longer-term settling resumes. Think of it as jet lag for a rock, a few days of mistimed afternoons while the new arrangement finds its rhythm. Those days are when accurate models earn their keep. Cohesion complicates the picture in both directions. Stronger than assumed cohesion can keep slopes locked, leaving the skin unchanged and our priors intact. Good news for stability. But only if we measured coherence correctly. Weaker than assumed cohesion can make local failures easier, producing subtle dust lofting or downslope creep. Neither outcome is catastrophic. Both are instructive. We must be ready to tell which happened by reading the post-flyby light curve, polarization signatures, radar speckle patterns, and thermal maps like a physician reading vitals after a strain test. If all of this feels uncomfortably conditional, that's the point. Gravity doesn't owe us drama. It owes us gradients. Rubble piles don't owe us symmetry. They owe us behavior. The pass is a lab we did not have to build. It will run for a few hours and leave clues that linger for years. Our job is to collect them with enough discipline that the 1% hinges swing our predictions the right way. And if you're searching for a single image to hold, take this. Earth as a hand passing close to a mobile of stones. Not touching, only moving the air. The mobile sways differently afterward, imperceptibly to the passerby, obvious to the one who hung it. We are both those people. The passerby on sidewalks, the careful hanger at the console. The sidewalk will remember a pretty dot. The console will remember a world whose dust learned to flow. From here, the story naturally tightens. If tides can retune the skin and spin, then tiny forces find new vectors. A 1% shift becomes a map-wide rerouting. Next, we follow that thread to its unsettling end. Why microscopic changes today can compound into macroscopic risks later, and how shotgun replaces bullet when structure doesn't hold. 1% change in surface. Years later, a new threat. It doesn't sound like much less than the difference between two coats of paint, but on a small world, 1% is not cosmetic. It's leverage. Change the texture of a few slopes, shuffle dust from here to there, alter how quickly the afternoon holds and releases its heat. And the tiniest push we met earlier learns a new direction, not by degrees you'd brag about, but by degrees that don't forget. Think of the pass as a hand over a piano, a brief chord struck across the body. The dust lifts, the boulders settle, the thermal keys rearrange. When the hand leaves, the music does not return to what it was. It continues in a new key, quietly, relentlessly. From that moment forward, every sunset on the asteroid becomes a slightly different engine. The recoil of light points a hair to the left instead of the right. The timing of the exhale shifts by a breath. The orbit files those differences under eventually, and eventually arrives. We've seen this in models that dared to zoom in. A 2023 analysis, call it Kim's, because someone has to put their name on the hard. Math showed how tiny, patchy changes in surface properties cascade through long-term predictions. Not a disaster movie, just a posture shift in the equations. A little more thermal inertia here, a little less there, and the diurnal push walks the semi-major axis a few kilometers farther than yesterday's best forecast. Multiply by seasons, then by years, and the return corridor tightens in one place, loosens in another. The map of safe and watch this redraws itself while nobody is looking. This is where dread doesn't shout, it whispers. You won't notice the danger in a single night's light curve. You won't feel it in the way the bright point slides across your sky. The change hides in the future's posture, how close approaches line up, how resonances flirt, how a keyhole you could ignore turns into a keyhole you can't. 1% is enough to bend coincidence toward appointment. You can also hear it in the arithmetic of ignorance. Our orbit fits come with error bars. They always will. After a close pass, we will shrink those bars, thanks to radar geometry and exquisite timing. But the moment resurfacing retunes the thermal engine, those bars begin to evolve under new rules. If we pretend the rules stayed the same, we get confident in the wrong language. If we admit the rules changed and keep watching, the confidence we earn is quieter, but real. The fear you might be feeling just now, name it correctly. It isn't impact tomorrow. It's compound interest. Small forces collect like pennies in a jar you forgot you were filling. One day, you open the cabinet, and there's weight where you expected air. That's how 1% behaves in celestial mechanics. Not a headline until it is. There's another path the 1% can take, and it's messier. If tides jostle something deeper, if a contact binary tightens or loosens, if a pocket of void trades places with a bracing column, then the spin state can lurch by a sliver. That sliver reassigns afternoon, and the diurnal push signs its name on a new line. Or the surface cohesion yields just enough to let fine grains migrate into hollows and shadowed clefts, cooling them, making those places hoard night like misers. Now the exhale favors different longitudes. The push has a new accent. Cascading uncertainty is not chaos for its own sake. It's the humility of systems. Every assumption we carried into 2029 about roughness, inertia, obliquity, and phase lags gets audited by what actually happened. Most will pass. A few will fail quietly. The quiet failures matter most. They are the hinges that swing the future by centimeters today and kilometers later. Kim's equations warned us, but equations are only true when their nouns are measured. After the pass, we will replace variables with facts where we can. Where we can't, we will bracket possibilities like adults. This is also where precision earns its salary. Polarimetry to sense texture, thermal infrared to map the day's breath, radar speckle to catch spin wobbles, occultations to draw silhouettes with starlight like a surgeon's pen. Each discipline is a hand on the dial, trimming the 1% until it's a half, then a tenth, then a nothing that stops mattering. Until then, we behave as if the 1% is real, because the cost of treating it as fiction is greater than the cost of over-measuring. Hold an image, a long highway at night, far ahead. A lane narrows where you can't see it yet. If your steering is off by 1 degree for a while, you drift toward the line. Nothing happens until it does. Then all the nothing becomes everything at once. In our story, the lane is a gravitational keyhole or a resonance that keeps inviting returns. The steering is the thermal push, retuned by small edits to a complicated skin. Keep both hands on the wheel. And if you're wondering where this could lead, you already know the next act. When surfaces move and engines retune, stresses redistribute. Slopes that survived the pass might fail quietly later, under the soft torque of sunlight or the slow twist of Yorp. A seam separates, a lobe loosens, a cluster of fragments becomes a family. The bullet becomes a shotgun, not because drama arrived, but because patience did. 1% opened the door. What waits beyond isn't certain, but it is possible. Structural instability that turns a single body into many, multiplying paths and turning clean predictions into clouds. That's where we go next. It's not a comet, but it might act like one. We've spent years filing small bodies into neat drawers. Comets wear veils of gas and dust. Asteroids are bare stone and shadow. The sky doesn't sign our forms. A rubble pile that has slept cold for eons can carry pockets of volatiles, ice buried under regolith, frost welded into pores, trapped gases in microcavities that never felt a real noon. Bring that body close. Let it bathe in sunlight a little stronger than it remembers, and the boundary between rock and comet turns porous. Start with warmth, the patient conspirator. Surface grains heat and share that heat downward. Cracks breathe. Voids thaw at their edges. A thin film of vapor forms where no vapor should be. Most days, that vapor has nowhere to go fast, but tilt the spin just so, open a pathway through fractured regolith, and pressure finds direction. A whisper becomes a draft becomes a vent. You do not need plumes. You can photograph from the backyard. You need grams per second, enough to loft dust, enough to nudge. Heat-induced mass loss, if it happens, will hide its drama in scales. A pinhole jet changes nothing you can admire, and everything a model must respect. Dust lifted from shadow to sun hovers, falls, and coats anew. A shallow mantle collapses and exposes something darker, rougher, quicker to store heat. Each cycle alters the local balance of morning and afternoon. The soft engine of sunlight gains a new collaborator, recoil from actual gas leaving. Now add the pass, with its tides and its little shakes. If micro-slumps open conduits, if fine grains sift like hourglass sand, buried volatiles can meet pathways they haven't seen since the body formed. Vapor finds the weakest link always, and the weakest link points wherever the surface just rearranged. For a while, the outgassing direction rides the weather of geology, not the calendar of orbits. You get a patchwork of tiny acts, each too small to headline, together enough to matter. Look at the body from a camera that cares about nothing but physics. You'd see faint curtains of dust near local noon, then none when the angle changes. A polar region that stays quiet until a seasonal sun finally climbs, then flickers on, a crack that exhales only when a boulder's shadow moves off it by a few degrees. You'd see the coma we're not expecting, not a grand, luminous halo, but a local fog, a habit more than a spectacle. And habits, accumulated, steer. Even if no vapor escapes, heat can still make mass walk. Thermal fatigue cracks rocks. Pebbles creep downslope at speeds you could outrace with your breath. Electrostatic lofting on sunlit ridges lofts fines just long enough to redeposit elsewhere. Every migration edits the surface albedo, the roughness, and the thermal lag that sets the tiny push metronome. The asteroid doesn't need to behave like a comet to borrow a comet's consequences. It just needs to change who gets warm, when, and for how long before the heat leaves. Unseen danger lives in the interaction terms. Outgassing recoils don't act alone. They superpose with Yarkovsky's thermal recoil and whatever Yorp is quietly doing to the spin. Turn the torque a little and you change the direction heat prefers to leave. Change the direction of heat and you retune the outgassing itself, because the open conduit now faces a slightly different afternoon. Feedback, not fireworks. A system is learning its new song. We prepare for this the way professionals always do, by refusing to be bored by small numbers. Photometry for brightness surges that don't fit rotation alone. Polarimetry for dust textures that betray grains in flight. Thermal infrared for patches that heat too fast and cool too slow. Radar for roughness that changed between passes. Speckle patterns that won't match their memories. Occultations for silhouettes where edges get fuzzier than rock can account for. If the coma appears, it also carries a second threat not to us directly, but to the body holding it together. Vents erode their rims. Dust that once armoured slopes becomes airborne and then is gone. A boulder undercut by a weak but persistent exhale eventually moves, and when it moves, the slope below it updates its mind. Each tiny failure is a vote. Enough votes and a region flips. The structure remains, but its confidence falls. You don't see a fracture. You see a neighbourhood ready to listen to the next suggestion gravity makes. This is the quiet bridge to fragmentation. We are not predicting fireworks in 2029. We acknowledge mechanics. A handful of vents, a handful of slumps, a handful of modest talks, and a system that once shrugged at its own weakness learns a new habit. Give a little when asked. That habit is how a contact binary loosens its embrace millimeter by millimeter. It's how a ridge that has survived every prior noon decides that this one is different. It's how a coherent block becomes a cluster with opinions. One day, maybe not this pass, maybe not the next, those opinions vote for separation. Not a single shattered headline, but a family drifting on slightly different truths. Their comas, their pushes, their spins no longer synchronized. A bullet becomes a shotgun not because something exploded, but because patience kept books. We will call it fragmentation because we need a noun. What really happened is that small forces were allowed to finish their sentences. Hold the four motifs close. Light reveals the fog no one expected. Silence lets us register that a new recoil has entered the room. Memory keeps the before, so the after can be believed. Breath gives us the pace to watch a habit become a hinge. From here, the story has to widen. Once pieces stop agreeing with each other, prediction stops being a single line and becomes a cloud with teeth. That's where we're headed next. How one object splits into many, and why a tidy calculation becomes a storm of possibilities. A single rock is one calculation. A shotgun blast is chaos. As long as Apophis remains a coherent body, the future can be drawn as one line with a halo of uncertainty around it. Frictionless in spirit, tractable enough for meetings, the sort of problem you can brief with a single slide. Fragmentation burns that slide. When one becomes many, every piece inherits the past but earns its own future, and the neat ellipse of possibilities smears into a weather map. Start with the simplest fracture. A contact binary loosens its clasp. Two lobes that once kissed under mutual gravity separate by centimeters, then by meters. The system keeps its total momentum, but the distribution of mass and spin changes. Each lobe finds a new rotation rate, a new afternoon, a new Yarkovsky push. Their mutual dance at first is gentle tidal tugs, tiny exchanges of momentum with crumbs shedding from the neck, but the trajectories diverge all the same. Yesterday's, the object becomes component A and component B, and the calculators sharpen their pencils because the soft engine now points two ways. Scale that up a notch. Imagine a ridge slumps, liberating a flock of fragments. Boulders the size of vans, football fields, fists, the largest stay loyal to the parent's path for a while. Their relative speeds measured in centimeters per second. The smallest feel the universe differently. Sunlight begins to herd them. Radiation pressure taps the pebbles on the shoulder and nudges them off. The Yarkovsky push becomes size-sorted, the tiny drifting faster, the big barely feeling it. What used to be a single momentum vector becomes a bouquet of slightly different ones, each petal a future return date, sliding away from its siblings by months, then years. Momentum exchange does not stop with the initial break. Fragments talk to each other through gravity for a time. Close passes within the family trade small kicks. Spin states are tuned by mutual tides. Ricochets of dust and gravel set off local avalanches that beget more dust and more gravel. Even without further catastrophes, cluster weather takes over eddies and shears in phase space that pull the cloud into filaments and knots. The camera that once tracked a point now tracks a swarm. This is how a bullet turns into a shotgun, not by glamour, but by accounting. Each fragment carries a sliver of the original risk and invents some of its own. Individually, the pieces may be less dangerous. Collectively, they enlarge the space of possibilities. Probability mass migrates from one tidy, low-likelihood corridor into many thin ones, some benign, some not, some near-term, some deferred by resonances you'd only notice after a decade of careful listening. The hard part is not the arithmetic. It's the humility to admit that arithmetic alone won't corral it without new measurements. Think like a navigator. We used to live on one covariance cloud, one fuzzy kernel of where the object might be on the B-plane, that imaginary target board perpendicular to the incoming path used for flyby geometry. Fragmentation takes the chalk and dusts the whole board. Each shard claims its own little cloud. Some overlap, some don't. A few stray into corridors, the so-called keyholes, where gravity promises a timed return. You can't weigh the risk by mass alone, because dynamics doesn't care about our intuition. A smaller fragment, with the right spin and thermal lag, can be shepherded toward an unhelpful corridor, faster than its larger parent would have been. Dust complicates everything. It's harmless to us, dangerous to certainty. A faint coma of sub-millimeter grains can bias photometry, making the body appear slightly brighter or larger. It can also lard the space around the fragments with glints that masquerade as companions. Models built for clean points on dark backgrounds begin to stutter. Instruments designed to lock onto a single centroid must negotiate with a fuzz. The cure is discipline, radar, when geometry allows, occultations arranged with precision, so silhouettes speak, multiband photometry that can tell rock from dust by color and phase behavior. There's a second, subtler escalation. Fragmentation rewrites the spin story for everyone involved. A freshly liberated shard is rarely a graceful spinner. It tumbles. Tumbling scrambles afternoons. Scrambled afternoons retune the Yarkovsky, push unpredictably until damping or sunlights talk, teaches the piece a calmer rhythm. During that unruly period, modeling is less forecast than fencing, probing, adjusting, admitting what you don't know yet, then measuring again at the next favorable geometry. If this all sounds messy, that's because it is. But messiness is not helplessness. It's a reason to widen the net. We'll need networks of small telescopes coordinated like an orchestra, catching light curves across time zones so tumbling solutions converge. We'll need radar time allocated with the assumption that the target might be plural. We'll need to treat non-detections as data. A fragment we fail to see at an expected brightness constrains size and albedo, and therefore the range of drifts we should expect. We'll need patience, but not the passive kind. The patient is an active kind who schedules, shares, refits, and repeats. There's a psychological shift too. A single body feels like fate. Many bodies feel like weather. You don't argue with fate. You plan for the weather. You have thresholds, playbooks, and alerts that escalate when certain corridors grow teeth. You accept that some days the forecast degrades before it improves, because new information moved the clouds, not because anyone did anything wrong. That posture is not fear. It's a professional posture for a universe that enjoys branch points. Light, silence, memory, breath. Let them keep time. Light to sort rocks from fog. Silence to sit with ambiguity until measurements arrive. Memory to compare nights that looked the same until one didn't. Breath to keep cadence when headlines try to sprint. If the swarm comes, we'll read it as carefully as we read the single point. And if it doesn't, if Apophis holds together and simply shudders, resets, and moves on, these preparations still buy us clarity. The act of getting ready is how uncertainty shrinks, even when nothing dramatic happens. We're walking toward a specific threshold now. Once you admit many pieces with many futures, the geometry of close approaches turns from canvas to pinball table. The same gravity that fractured plans also sets corridors, narrow gates in the B-plane, such that a pass-through one returns the object years later on a schedule of the planet's making. For one thing, those keyholes are few and far between. For a family, there may be many and thin. A lace you can only see when you stand close. That is where we go next. The geometry of narrow doors. How a swarm meets a planet's gravity not as a single guest, but as a crowd drifting towards specific, unforgiving thresholds, and why a close pass in 2029 could script echoes for decades if even one fragment finds the exact wrong corridor. Hit the exact wrong corridor, and it comes back. A close pass is not just a near miss, it is a machine. Picture the plane perpendicular to the incoming path, the B-plane, like a transparent board hung in space in front of Earth. Every possible trajectory during the flyby punches a dot through that board. Most dots mean goodbye. A few dots fall into razor-thin slots, keyholes, where Earth's tug retimes the orbit so that the object returns on a later date, phased to meet us again. Miss the slot by a kilometer, and nothing happens. Thread it, and the calendar writes a sequel. Keyholes are small in a way that offends intuition. You spend millions of kilometers approaching a planet, and the difference between never mind and see you in X years is a gate that could be narrower than a city. It isn't dramatic to look at. It's arithmetic with teeth, geometry, timing, and gravity conspiring, so that one very specific missed distance becomes the seed for a future encounter. The pass in 2029 will spray outcomes across the B-plane. Most will stick to harmless. The fear lives in the thin places. How do we know where those gates are? We scatter outcomes like confetti Monte Carlo style. Take the best fit orbit and the best fit physical parameters. Then sample the uncertainties, thousands to millions of tiny variations. March each imaginary Apophis through the 2029 flyby. Let Earth bend the path, push time forward, and see which futures return, and when. Plot those endings against the beginnings on the B-plane, and the keyholes reveal themselves like dew on threads, filaments of bad timing. You could step over if you only knew where your foot would land. History offers a number that won't leave the room, 2036. Years ago, it was a headline, then a rumor, then a retired worry, as measurements improved. That arc is the point. Probabilities move when knowledge moves. After 2029, the board gets redrawn with measurements in place of priors. Some keyholes will vanish, others will sharpen. A few may appear where earlier assumptions were too smooth to let them show. Dread doesn't come from the number itself, it comes from what the number represents. How a single night, in 2029, can tune decades of future geometry. Fragmentation makes the board busier. One body means one cloud of dots. A family means many, each cloud offset by a little spin, a little sunlight, a little past jolt. A small shard with a tumbling spin can drift differently under thermal whispers and arrive at the B-plane with its own target pattern. Keyholes that the parent would have missed can catch a child. The shotgun multiplies not just paths, but gates. Resonances wait downstream like clockmakers. Suppose a return lines up so that Apophis' new orbital period forms a simple ratio with Earth's 6 to 7, 5 to 6, 7 to 8. That I, gravity's way of making appointments. Each loop adds a small correction to the timing. If the object keeps meeting Earth at nearly the same phase, those corrections echo, sometimes cancelling, compounding. The pinball table is not random, it is patterned, and the patterns love repetition. One wrong corridor in 2029 can lock the rhythm for a very long song. Stand close to the board in your mind. You'll see three kinds of points: the vast safe field, the threads of keyholes, and, between them, a fog of almost keyholes, near-miss conditions that don't schedule a precise return, but do herd the orbit toward later opportunities. A keyhole isn't only a door, it's also a lane that steers you toward more doors. That is why the error bars we carry into 2029 matter so much. If the cloud of uncertainty splashes across a keyhole, you can't file it under zero and go to bed. You must shrink the cloud until it clears the thread, or concede that vigilance is now a recurring bill. This is existential dread without melodrama. There is no siren in space, no red light, no countdown you can hear. There is a map with hairline thresholds, a date on the calendar, and a species that prefers certainty, learning to live inside probabilities that get updated by work. Dread grows when the public hears no threat as no work required. The truth is steadier. No threat today means keep measuring, because the machine of a flyby does not care whether we're tired of the topic. Our four motifs keep the hand from shaking. Light shows where the dot hits the board, precision in timing, angle, and brightness that narrows the cloud. Silence is the discipline to let data accumulate before we announce closure. Memory is the archive of pre- and post-flyby states, so the difference is undeniable. Breath is the cadence. We will step through 2029, then exhale into the simulations again, this time with sharper inputs and fewer guesses hiding in the margins. There's a temptation to think in binaries: on, off, safe, not safe. Keyholes refuse that comfort. They are analog in spirit, digital in consequence. You're out, 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 then in. The Monte Carlo runs will look like weather: 1,000 futures sunlit and harmless, a handful shaded with returns that deserve a name and a date. Well, brief those names and dates soberly, with context, with the math that explains why the probability remains low and the obligation remains high. Low probability over decades is exactly the kind of risk that punishes boredom. Imagine the pinball table from above. Bumpers are planets, lanes are resonances, slingshots are close passes. We didn't choose the layout, but we do choose how well we read it. The 2029 encounter is one of those shots that will define whether the ball kisses a bumper sweetly once or learns a loop that brings it back around for more. If fragmentation is in play, several balls may be rolling at once, some lighter, some more easily nudged by the table's lights. If you need one last image, take this: a narrow hallway in a cathedral of stone. Most footsteps pass and fade. A few find a perfect arc and echo back, delayed, haunting. The hallway is the keyhole. The echo is a scheduled future. The cathedral is the solar system. We can map the hallways. We can teach ourselves which ones matter. We can place microphones in the right places and listen. And we can accept, like adults, that listening does not equal fear, it equals care. From here, the lens widens again. Keyholes are doors, but resonances are rooms. Once a return is scripted, the rhythm of repeated encounters can trap a body into a pattern we must break or learn to live with. Next, we enter the resonance hall and count the clocks. Like clockwork, it returns, unless we break the clock. Resonance is gravity's way of keeping time. Give two bodies orbits whose periods form a simple ratio, say. Apophis loops the sun 7 times while Earth loops 6, and the geometry starts repeating. Close approaches recur near the same places in space, at nearly the same angles, like a metronome clicking behind a melody you can't stop hearing once you notice it. Not every pass is close. Not every close pass is dangerous. But resonance herds possibilities, turning anywhere, anytime, into roughly here, roughly then. And that regularity is where both planning and anxiety live. Imagine the solar system as a floor of nested tracks. Earth's lane is steady. Apophis lane is almost steady, but the tiniest push reshapes it between laps. If a past flyby nudges its period into a near-rational ratio with ours, gravity keeps setting up the same shots. One approach arrives a few days early, the next a few days late, then click the phase lines up again. With each near return, timing errors can amplify or shrink, and the long arithmetic of small forces decides which way the trend goes. That is the trap. Not a single door to avoid, but a corridor of recurring chances to be in the wrong hallway at the wrong moment. The math is clean and cold. Change the semi-major axis by a whisper, and the orbital period shifts by another whisper. Stack whispers over the years, and you have a voice. That voice determines whether the next Earth-crossing interval shortens, lengthens, or repeats, and whether a future B-plane shot lands nearer to a keyhole thread or farther. When resonance is in play, the map of outcomes collapses from a wide plain into a braided river. Fewer channels, faster currents, higher stakes for being in the wrong braid. We are not powerless here, but we are accountable to precision. If we misjudge the spin, we misjudge the thermal push. If we misjudge the surface, we misjudge the lag between noon and the infrared exhale. If tides or outgassing have quietly edited either, then the period we write down today is the wrong seed for tomorrow's return date. Resonance punishes loose inputs because it rewards consistency. Get the sign of the tiny drift wrong, and the metronome clicks you toward the echo rather than away from it. This is where the anxiety earns its adjective, mathematical. The dread is not cinematic, it's procedural. It's knowing that 0.1% error in period today becomes days of phase error years from now, and that days of phase error are the difference between a harmless pass and a corridor that deserves its own briefing. It's living with the knowledge that uncertainty doesn't spread evenly. It funnels along resonant lanes where the same mistakes get the same opportunity to matter again. Resonance also amplifies the mischief of fragmentation. A family of fragments means a family of periods, each one near but not equal to the others. Some land close to a resonant ratio, some just outside, and the Yarkovsky, Yorp duet keeps retuning them differently. Over time, the swarm stratifies. A few pieces get shepherded into repeating geometries, others wander off into safer, duller space. The problem stops being what will Apophis do, and becomes which of these siblings learns the rhythm wed rather it didn't. One metronome becomes several, each ticking at a slightly different tempo. If this all feels abstract, translate it back into instruments. Resonance turns our job into clock maintenance. We need period measurements so precise that the next beat lands where the ephemeris says it will. We need spin solutions that track the drift sign, not just its existence. We need thermal maps that stop being sketches and start being engineering drawings. We need light curves that don't merely repeat, but align with geometry in ways that leave no space for maybe. And yet, the real world is messy on the nights we need it most. Clouds roll, telescopes break, a solar storm curtains the ionosphere, hurting radar signal quality and scrambling communications. A satellite collision throws stray glints into an otherwise clean field. The resonance trap doesn't spring because the universe is cruel. It springs because timing mistakes accumulate when we are careless or unlucky. That's the connection we have to make explicit before we move on. The elegance of the celestial clock meets the fragility of the human one. Hold the motifs to steady your breath. Light is our metronome photons counted, phased, and cross-checked. Silence is the discipline not to announce case closed while the beat is still resolving. Memory is the archive that lets us detect the small, steady drifts that retune the clock. Breath is the cadence of campaigns that span seasons. Observe, reduce, compare, repeat, even when the sky is unglamorous and the graphs look boringly consistent. Boring is how you escape the trap. There is a temptation to treat resonance like fate if the ratio lands here. We're stuck. We aren't. The ratio's near misses live in ranges, not knives. Slightly different periods mean slightly different phases at the next crossing, and the sign of the thermal drift can move us outward or inward between beats. In principle, even a mild, well-timed deflection mission could detune the system, break the clock by changing the period just enough to step off the worst lanes. Policy lives downstream of measurement, but measurement is what earns policy's confidence. The psychological trap is subtler. When the public hears that a previous resonant concern, 2036 for instance, was retired, they learn the wrong lesson, that we were worried for nothing. The right lesson is that updated measurements moved the system off a bad lane. The work worked. If 2029 sharpens everything and the worst threads thin or vanish, we should celebrate, but celebrate process, not luck. And we should fund the kind of global coordination that makes repeating that success probable rather than hopeful. Look again at the imagined metronome. Tick, tick, tick. Each tick is a future Earth-crossing interval. Each interval is a chance to rehearse our capacity to measure under imperfect conditions. Can we keep the clock if the sun throws a geomagnetic tantrum on the exact night we most need radar? Can we maintain coverage if a critical southern observatory loses power? Can we trust our calibration chains if a small coma appears and biases photometry by a few %? The resonance problem and the infrastructure problem are partners. One magnifies the cost of failure in the other. So we accept the anxiety and we teach it to behave like diligence. We design observing campaigns that assume a bad night will arrive on schedule. We duplicate key instruments where budgets allow. We share ephemerides and raw data across borders and time zones, so a lost night in one place becomes a busy afternoon in another. We write playbooks that treat nearly resonant return, not as a headline, but as a maintenance task. Keep the period pinned, keep the spin signed, keep the thermal engine characterized, keep the B-plane cloud off the threads. Like clockwork, it returns unless we break the clock. Breaking a celestial clock means changing numbers by small amounts at the right times. Before we contemplate that, we must be honest about the human clocks that can fail us first. The telescopes, the satellites, the power grids, the coordination itself. That is where we go next, the infrastructure test, because a perfect model is useless on the night the instruments go blind. The same day we need perfect measurements. The sun might disagree. We like to imagine clean nights, dry air, steady seeing, power grids humming, dishes slewing on time, clocks locked to the heartbeat of GPS. But the solar system is not a stage set. It is the weather. The sun throws fits, magnetospheres ring like bells, currents crawl through the ground where we would prefer silence, and on precisely the nights when timing matters most, when the B-plane needs dots, not metaphors, the environment that feeds our instruments can turn on them. Start with a flare. A bright spit of ultraviolet and X-rays reaches Earth in 8 minutes. Hours later, the coronal mass ejection arrives. A billow of plasma, a magnetic field lines coiled like spring steel. If its orientation couples well with ours, the magnetosphere cracks open. Charged particles pour down. Auroras bloom at latitudes that aren't supposed to host them. That beauty is a symptom. Ionospheric density changes. Radio frequencies bend or die. Long baseline radar grows static in its veins. The same radar we count on to carve rotation from uncertainty can, for a night or 3, lose its edge. Now, walk through the network. Optical telescopes are less allergic to geomagnetic storms, but not immune to chaos. When power grids groan under geomagnetically induced currents, observatories ride those grids. UPS systems are buffers, not miracles. A brief sag at the wrong moment, and the mount freezes, the dome stalls, the calibration sequence collapses. Clouds, of course, need no solar storm to ruin a plan. They are their own empire, which is why coordination is everything. Multiple sites, staggered longitudes, redundancy by design rather than accident. Still, it only takes one common mode failure, an ill-timed global storm, a satellite outage that removes precise timing to turn a robust plan into a wish. Timing is the quiet spine of everything we do. Telescopes that don't agree on the second can't agree on the spin period. Radar that can't trust its ephemeris can't frame the echo. Occultations that miss their predicted path because a network clock hiccuped can't trace the silhouette we need. We live by timestamps that ride on GPS signals, and GPS lives above us in a ring of machines with long conductive tethers to the Sunday. A big storm can turn those tethers into antennas. Errors creep in, some receivers hold fast, others drift, and the once boring act of timekeeping becomes a variable we must measure and correct. Even without a solar tantrum, the sky we built can make the sky we study harder to read. Thousands of satellites now cross every long exposure like slow scratches. Software can subtract streaks. Clever schedulers can dodge the busiest belts. But there is a threshold where subtraction becomes conjecture. The same satellites reflect sunlight at odd angles. Specular glints masquerade as companions or fragments. When we most need clean photometry to pin, spin, and brightness, a constellation's rush hour can wash our field in artifacts. Worse, a collision at the wrong altitude. A single breakup can seed a debris bloom that fattens the streak count overnight. It's not an apocalypse, it's attrition. A few % more frames spoiled here, a few % more false detections to vet there, and the cadence we promised ourselves in the planning document starts to slip. The resonance trap loves slippage. It converts missed beats into fatter error bars, and fatter error bars into clouds that overlap keyholes we thought we'd cleared. Think about radar again. Planetary radars are few, their nights precious, their maintenance non-trivial. A storm that saturates the ionosphere can scatter the beam. A downlink problem at a partner facility can cost the coherence we rely on for shape reconstructions. A regional power outage can mute a transmitter at the hour we'd scheduled months in advance. The cure for this fragility is not a heroic shrug, it's diversity. More than one facility, more than one path for distribution of ephemerides and raw data, more than one set of eyes doing reduction so that bad assumptions don't echo unchallenged. Coordination is a human word for a celestial need. We schedule occultation campaigns like emergency drills, observers across continents on back roads with portable rigs, watching a star wink as the asteroid passes in front of it. That wink draws a chord across the body. Dozens of chords make a shape, but storms can hide the star. Cloud decks don't respect heroic intent. When half the chords vanish into weather, the shape solution grows shy, and shy shapes breed bolder uncertainties downstream. We mitigate with overbooking more stations than we need, and by rehearsing handoffs, so that if one region fails, another region can extend its night into our morning. There's a subtler, systemic fragility. Software. Pipelines that handle routine nights with grace can choke on unusual ones. Add satellite streaks, auroral glows, power transients, and ionospheric phase noise, and quality control flags start to bloom. The temptation then is triage, skip the ugly frames, keep the pretty ones. But the ugly frames might be where the spin change first shows, where a faint coma lifts, where a polarization angle hints at dust on the move. We need pipelines that degrade gracefully and humans on call who know when not to trust the automation they wrote. And budgets. The infrastructure test isn't only physics, it's policy. Backups cost money. Redundant time sources require hardware, maintenance, and people. Sharing raw data across borders demands trust and agreements that live longer than an election cycle. When we say we will keep the period pinned, we're pledging to support a scaffolding of contracts, training, and cold nights. A single year of neglect can undo 3 years of robustness. Let the 4 motifs keep us honest. Light, more than photons also, the power that keeps instruments alive, and the reflections we must learn to subtract without hallucinating. Silence, not the absence of storms, but the discipline to design around them, to accept that some nights fail, and that failure was expected, budgeted, and absorbed. Memory, meticulous logs, what worked, what failed, which cables hummed, which receivers lied when the KP index spiked, so the next storm doesn't teach us the same lesson twice. Breath, not sprinting. Campaigns that assume attrition and still succeed because the cadence was paced for a marathon, not a headline. Now, the part we'd rather not admit. The satellites we depend on to navigate, forecast, and time our measurements can become accelerants when things go wrong. A geomagnetic storm swells the upper atmosphere, increasing drag. Satellites drop a little, operators fire thrusters. Collisions that were unlikely become a little less so for a while. A single conjunction handled poorly can spray shards into lanes that thousands of other machines must now thread. The more crowded the sky, the more normal operations become a source of noise for the very observations that keep us safe from the natural sky. And yet, fragility is not fatalism. We can harden GPS and its cousins against storms with better shielding and smarter software. We can deploy ground-based time standards that hold phase when the sky misbehaves, then reconcile after. We can pre-plan storm modes for radar alternative frequencies, different integration schemes, backup schedules, and fund the staff who know how to execute them at 3 a.m. We can build global calendars that treat peak solar cycle months as high risk and saturate those windows with redundancy. We can ask commercial mega-constellations to publish precise ephemerides and agree to night-preserving coatings and orientation regimes. Not perfect, but better and better is how error bars shrink. If we pass the infrastructure test, the resonance trap becomes a math problem again. If we fail, the math goes feral. Measurements slip, uncertainties fatten, and the narrow corridors we were so proud to avoid blur back into possibility. That's why the story of Apophis is as much about us as it is about a rock. We will either be the civilization that could keep time on the night it mattered, or the one that blamed weather and streaks and promised to do better next pass. Breathe. Plan for the sun to disagree. Budget for outages. Train for nights that don't cooperate. Build backups that are boring until they save the day. And when a storm does arrive on the exact night we circled months ago, let the system yawn, flex, and carry on because fragility was acknowledged and engineered around. From here, the lens narrows to the ring we built that can make matters worse in a different, cascading way. If one satellite becomes 2,000 pieces at the wrong altitude, our problem with measurement becomes a problem with the environment. That's the next threshold. How a crowded sky can turn a single accident into a chain reaction and make the truth harder to see just when we most need to see it. One misaligned satellite, one collision, one blackout. Crowding turns orbit into weather. We built a shining ring of helpers imagery, timing, communications, and in doing so, we made a new atmosphere. Fast, thin, and vulnerable to chain reactions. When two pieces of hardware meet at orbital speeds, they don't dent, they multiply. Shards, the size of pebbles, inherit lethal energy. Paint flecks become sandblasters. A single mistake writes a storm that other machines must now fly through. This matters on the night we most need truth. Photometry wants clean backgrounds and honest stars. Radar wants a quiet ionosphere and known reflectors. Occultation teams want unbroken chords across a blinking star. Now put streaks through every long exposure, glints that mimic fragments, RF noise from hurried avoidance burns, and an unexpected debris cloud that swells, drag, and scrambles ephemerides. The sky hasn't changed. Our picture of it has. Kessler syndrome is not apocalypse so much as arithmetic. Enough objects in the same shell means enough chances for conjunctions. Enough conjunctions mean enough propulsive dodges. Enough dodges raise the odds of mistakes. A single breakup fattens the shell, and the cycle tightens. Most days, operators are careful, and the software is good. Most days are not all days. On the wrong night, routine conjunction becomes fragmentation event, and the region we plan to observe through becomes a snow globe. What does a lying sky look like at the console? A light curve that brightens by 0.5% exactly as a specular flare crosses the field. A candidate fragment that vanishes when the constellation's geometry changes. A timing residual that looks like a spin shift but came from a GPS receiver hunting for lock after a minor storm. A radar echo that smears because an ionospheric disturbance nudged the phase just enough to fool the reconstruction. None of these deceptions is malicious. They are side effects of asking the same volume of host measurement and machinery at once. We can still get the truth, but the process grows heavier. Frames need vetting with cross-site comparison. Did the anomaly appear at the same sidereal time elsewhere? Catalogs must be fresh enough that new launches and maneuvers don't masquerade as rocks. Pipelines need streak-aware photometry that models and subtracts trails without inventing companions. Polarimetry can help dust and satellite sheen polarize differently, but only if the instrument stays stable through power sags and temperature shifts. Every tool becomes a two-part dance. Extract the sky, subtract ourselves. There's a deeper kind of corruption that isn't technical, it's psychological. When the field is noisy, our priors get louder. We see the fragment we fear in a streak that fits the narrative. We explain away inconvenient null results because the night was messy. Humility is the antidote, not the kind that shrugs and gives up, but the kind that writes down every assumption and marks which ones the night could have violated. When we say spin changed, we check first that the clock didn't. When we say coma, we check that a satellite flare didn't pass behind the target. When we say fragment, we prove the point moved with the right parallax and color. Light, silence, memory, breath, let them do their work. Light, but measured with skepticism, cross-banded and time-stamped twice. Silence, meaning patience, while teams in other longitudes replicate the anomaly without our artifacts. Memory, not just of the asteroid, but of the sky we built, launch logs, attitude histories, flare statistics, so subtraction is based on history, not hope. Breath, the steady cadence of campaigns designed to survive spoiled frames without panicking the model into fantasies. If the worst happens and a dense shell becomes a debris field, the damage to certainty exceeds the damage to hardware. Months of elevated streak rates and false positives can starve the very time series that keeps resonance risk tame. Error bars thicken, B-plane clouds blur, keyhole threads reappear in forecasts we thought we'd cleared. The object did not grow riskier, our picture did. The only honest response is to expand the network and slow the breath. More observers, more wavelengths, longer baselines, and public dashboards that admit when the data quality fell and how we compensated. This is the moment to recenter our posture. The sky is complicated, and we helped complicate it. That's not an indictment, it's a responsibility. We earn trust by narrating failure modes as openly as success, by publishing raw frames alongside reductions, by flagging nights when the instrument misbehaved, by refusing to squeeze certainty from noise because a headline wants closure. Real safety comes from statistics married to conscience. From here, the lens turns back to humility at a different scale. The universe has a habit of laughing at models that feel complete. Even our best telescopes have rewritten first principles, surprising us with galaxies too early, chemistries too complex, structures we thought impossible. If the sky can lie because we clutter it, it can also surprise us because we were wrong. The next part belongs to those reminders, the beautiful ways the universe has broken our tidy pictures, and why that's a gift when we face a rock that may change its mind. We built perfect models, then the universe laughed. Not cruelly, joyfully, like a magician revealing a card you were certain you hadn't picked. A new mirror opened in deep space, cooled until it could taste warmth itself, and the first images were not just pretty, they were impolite. Galaxies strutted onto the stage earlier, brighter, more organized than our rehearsals allowed. Chemistry showed up where we'd filed it under too soon, with hints of complex organics swaying in the light of infant stars, as if to say, you underestimated the speed of beginnings. Call it what it was, a paradigm politely shoved. We had drawn the cosmic timeline in tidy chalk first light here, structures after, chemistry much later, and the chalk dusted our sleeves when we clapped. The new telescope did what good instruments always do. It didn't correct us with a single sentence. It handed us a stack of exceptions. Disks around young suns riffling with signatures we weren't ready to see. Knots of matter behaving like cities long before the zoning board approved them. Backlight through dust, revealing scaffolds we had insisted were still blueprints. The message wasn't, you were wrong about everything. It was, you were neat about something that is not. Wonder came first. Doubt followed, the healthy kind. If the largest scales of our story can arrive early and be busy, what else are we smoothing with assumptions because the math is prettier that way? This is not a crisis. It's the sound of science breathing inhale surprise, exhale revision our four motifs in motion. Light delivering information we didn't know how to ask for. Silence giving us time to listen before we argue. Memory archiving the before so the after means something. Breath slowing the cadence so we rewrite with care. Why pause here in a film about a near-Earth pass? Because this is the posture we need when a rock rewrites its own small rules. If a space telescope can make galaxies show up early, a flyby can make our neat local timelines spin, heat, drift, go noisy at the edges. The models we lean on are not lies, they're ladders. We climb them to see farther. Then we build new ones because the view changed. The analogy tightens when you think about noise. In the early days of gravitational waves, every murmur looked like an accident. Wind, trucks, mirrors twitching at the scale of atoms. We learned to distinguish the world from the world's whisper. We tuned out the chatter until colliding black holes sang through it. That discipline teaching instruments what not to hear, so they can hear what matters, will serve us again when the sky we built adds streaks, when the sun flexes, when Apophis light curve begins to stutter with a truth that's smaller than a headline and larger than a guess. The new telescope's gift was not only results, it was humility with receipts. It reminded us that model means best story so far, that confidence without curiosity is a ceiling, that hard-won priors must be held lightly enough to lift. We can love an equation and still let a photon overrule it. We can brief the public in calm sentences and still admit, in our notebooks, where the map softens at the edges, hold one image, a gallery wall of impossible things that are simply happening order, where we expected mess, molecules where we expected blankness, arcs and lenses tracing gravity's script in fonts we hadn't learned to read. None of this broke physics. It broke habits. And that is the point. Habits are fast. The universe is patient. When patience wins, knowledge grows. So when we stand under April's sky and watch a bright dot slide through human infrastructure, we'll carry this lesson, prepare to be surprised, and budget for it. If the spin refuses to settle, if thermal breath chooses a new rhythm, if a faint coma blurs what asteroid means for a season, our job is not to defend yesterday's neatness. It's to let today's evidence sharpen tomorrow's promise. From telescopes that saw the first cities of matter too soon, we walk to instruments that catch the quietest quakes of space-time. Another triumph of doubt turned into clarity. Gravitational waves taught us to weigh the invisible by listening to ripples. That same patience can help us weigh the god of chaos better than light alone. We now detect black hole collisions from 1 billion years ago, but we still don't know Apophis mass. That contrast isn't an embarrassment. It's a syllabus. Gravitational wave astronomy took a century-old prediction, wrapped it in stubborn engineering, and turned the faintest tremors of space-time into facts about invisible giants. We learned to coax a signal from noise so delicately that mirror jitters smaller than a proton became the drumbeat of colliding black holes. That discipline, the humility to doubt, the patience to calibrate, the joy of being corrected, can teach us how to pin down a rock that will pass inside our mechanical sky. Consider what LIGO, Virgo, and Cagra had to become. Lasers locked in arms, kilometers long. Seismic isolation that makes earthquakes feel like whispers. Vacuum so clean a molecule is a celebrity. Then the harder part, subtracting the world. Trains, wind, thermal creaks, a mirror's sigh when the building cools. Every earthly habit impersonates a cosmic ripple. The collaboration didn't magic those away. It learned them by heart, modeled them, and left a residue where gravity itself was speaking. Signal versus noise wasn't a slogan, it was a practice. Our problem with Apophis is smaller and closer, but the lesson rhymes. If you want mass, you don't guess. You weigh indirectly but honestly. Radar range Doppler gives geometry and spin. High-precision astrometry nails the ephemeris. Mutual perturbations during the flyby, tiny tweaks to the path caused by Earth. And, in return, by Apophis' own pull, let us back out gravitational parameters. Thermal data sets the context. Density implied by size versus brightness. Inertia implied by day-night temperature swings. None of those alone is mass. Together, with priors that admit uncertainty, they become a weight with error bars that mean something. Gravitational wave people talk about matched filtering. You compare noisy data against a library of theoretical waveforms and see where the overlap sings. Planetary defense needs its own matched filters. Shape models that can actually reproduce the radar echo. Spin states that fit light curves and polarization. Thermal models that don't just look pretty, but predict the phase lag in infrared brightness as afternoon breathes out. When a dataset doesn't match, we don't bend the data. We retire the template. That's the humility we borrow from the ripple hunters. Calibration is where bragging rights are earned. LIGO injects fake signals, hardware hisses that pretend to be black holes, to test whether the pipeline blinks or believes. We can do the same in spirit. Time synchronization cross-checks. Independent time sources at radar and optical facilities. GPS backed by ground clocks, with audit trails that survive storms. Photometric standards, observed bracketing every Apophis session, so a 1% drift in instrument sensitivity doesn't masquerade as a spin change. Thermal instruments pointed at boring asteroids with well-known properties. The same nights we point at Apophis, so our pipeline proves it can reproduce boring before it claims interesting. The ripple lesson also warns us about confidence. Early detections came with fat error regions in the sky. Only as more instruments joined, baselines grew, and calibration matured did the error ellipses shrink. We must earn our own shrinkage. A single radar night is a blessing, not a verdict. A single clear photometric run is a line, not a page. Put nights together across longitudes. Stack radar sessions. Combine instruments that disagree in complementary ways. Let the disagreement do its job. Expose assumptions we forgot we were making. There's poetry in both fields, though we don't always admit it. Black holes tell us stories in strains rising, merging, ringing. Small bodies hum in light, bright, dim, bright, each beat a facet, a slope, a shadow. Both are heard best when we stop romanticizing certainty and start building systems that celebrate revision. That's scientific humility. Not meekness, but the courage to be improved. So what does humility look like between now and April 2029? It looks like checklists that foreground the hard questions. Are our shape and spin solutions multi-instrument, consistent optical, radar, thermal within stated errors? Are our time bases verified by redundant standards every observing night? Have we quantified how much a 1% calibration slip would move the B-plane cloud? Do our thermal models reproduce known asteroids this season before we apply them to Apophis? Are our pipelines streak-aware and storm-aware, with humans rehearsed for manual overrides? Do we have international handoffs written down? Who observes when chilly clouds out? Who runs radar if the ionosphere flares? And crucially, are we expressing no threat with the same caveat grammar we use in the lab? Gravitational wave astronomy also teaches patience with false alarms. Some blips look delicious, then decomposed into ground truth, literally ground. Well, have our blips. A light curve quirk that turns into a satellite glint, a thermal hotspot that turns into a calibration lamp left on, a radar speckle that was phase noise. Each time we correct without shame, our real detections get a little more believable. Now, about mass, the line we began with, we can make meaningful progress if we treat the flyby as a weighing machine. Earth's gravity will bend Apophis' path by a calculable amount. Precise before, after astrometry lets us tighten the gravitational parameter that best fits the bend. If we have a credible size from radar shape modeling and thermal radiometry, density and porosity follow, with ranges that tell us how rubble-like the interior must be. Those ranges feed directly back into the thermal engine model. The engine sets the long-term drift's sign and strength. The drift moves the cloud relative to keyholes. The keyholes grow teeth or dull edges accordingly. One number never stands alone, and when the number refuses to settle, we say so. We publish the bounds and build the next plan around them. That is also part of the ripple lesson. Limits are findings. Upper limits on outgassing are constraints. Non-detections of a coma are still pages in the log. A failure to see a predicted phase lag is a reason to revisit roughness assumptions, not to squeeze a curve until it confesses. Hold the motifs while we set the stage for what's next. Light not just photons from a rock, but the metrology that keeps our clocks and gains honesty. Silence, letting long campaigns accumulate, so single nights don't drive policy. Memory, a before-after architecture that makes subtle changes legible. Breath, the pacing that respects seasons, funding cycles, and the fact that April will not grant do-overs. We've learned from ripples how to be precise with the invisible. Now, we turn that precision into a shopping list. Before 2029, there are 7 things we must measure or bound so tightly that probably becomes a number you can lean on. Mass, rotation state, thermal inertia, albedo and roughness, shape and potential contact binary nature, cohesion, regolith depth, and any hint of volatile activity. Next, we count them clearly, calmly, 1 through 7, and define how to get each one in hand. You can't predict what you haven't measured. 7 questions decide whether probably becomes a number we can lean on. Each has a tool. Each tool needs nights that cooperate and teams that refuse to round off the edges. 1. Mass and bulk density. Everything hangs from weight. We get it indirectly. Compare the pre- and post-flyby trajectory with exquisite astrometry. Then solve for the gravitational parameter that best fits the bend. Add a credible size radar shape, plus thermal radiometry and density follows, with porosity limits that tell us whether we're dealing with gravel held by a whisper or stone with backbone. Get this wrong, and every downstream drift and keyhole estimate inherits the error. 2. Shape and possible contact binary nature. A sphere is merciful. Apophis is not. Range Doppler radar carves silhouettes and limb slopes. Speckle tracking refines concavities. Multi-chord occultations lay clean cuts across the body. If 2 lobes kiss beneath a rubble neck, The moment of inertia and tidal response change, and the spin we think we measured can pivot under stress. Shape isn't decoration. It's the geometry that tells heat and gravity where to work. 3. Rotation, state, and stability. Principal axis spinner or subtle tumbler. Obliquity sets where afternoon lives. Period drift reveals sunlight's torque. We need harmonized solutions from light curves, radar echo broadening, and polarization timing, not one dataset flattering our favorite fit. Even a fractional change in period, or a half degree in tilt, can flip the sign of the long-term thermal drift. If tides retune the wheel during flyby, we have to catch the new setting fast. 4. Thermal inertia and roughness. How quickly does the skin take warmth in and let it go? Thermal infrared maps the day's breath. Phase lag analysis places numbers on lag and beaming. Polarimetry whispers about grain size and texture. Higher inertia lengthens the afternoon. Roughness beams photons preferentially. These are the dials on the Yarkovsky engine. Move them by 1%, and decades later, geography moves with them. 5. Albedo and true size. Brightness lies if albedo is assumed. Combine radar-derived dimensions with reflected light photometry to stop guessing. Diameter errors become volume errors, which become density lies, which become false comfort. We pin albedo across filters so color trends don't masquerade as comb or dust. 6. Regolith depth, cohesion, and internal architecture. Is the skin talc or gravel? Do slopes sit at their limits or yawn beneath them? Polarization phase curves, thermal beaming, and radar roughness indices bound grain scale. Laboratory-anchored models map those bounds into cohesion ranges. If the interior is a patchwork of voids and bridges, tides will test them. Knowing how near to failure the skin already lives tells us what a close pass can plausibly rearrange. 7. Volatile activity and dust mobility. Rock by label can borrow comet behavior. We set upper limits on outgassing with sensitive photometry and high-phase imaging. We watch for transient brightening that rotates with the body rather than with our geometry. Even grams per second matter. A pinhole jet is a recoil term the orbit can feel over years. Thermal fatigue, electrostatic lofting, and micro-slumps are the quiet accomplices. If they're present, the skin is writing a schedule we need to read. Put together, these 7 turn poetry into steering. Mass plus size yields density. Density and structure inform tidal response. Rotation and obliquity steer the thermal engine. Inertia and roughness set its throttle. Albedo keeps volume honest. Activity and dust motion add a second recoil. The output is a drift with a sign, a magnitude, and error bars we can defend. That drift moves the cloud on the B-plane relative to keyholes and resonance lanes. That's the game. Execution matters as much as equipment. Redundant time standards so clocks don't invent spin changes. Cross-site observing plans that assume the weather will pick the worst night. Pipelines that are streak-aware and storm-aware with humans ready to override. Boring control targets every session so calibration drifts don't pass for physics. Public logs so the archive remembers which cable hummed when the KP index spiked. Hold the motifs while the checklists grow. Light as information, not just illumination. Silence as patience while disagreements resolve. Memory as a before-after ledger that makes small edits legible. Breath as pacing that treats April as a checkpoint, not a finale. And a caution before we celebrate the plan. Even perfect inputs can go sideways inside a black box. Models trained on yesterday's asteroids can smile at tomorrow's anomaly and say normal. Confidence is a tool, not a verdict, which means that after we weigh the god of chaos with every instrument we have, we still need to look over the shoulder of our own algorithms and ask whether certainty was earned or inferred. Next, we face that risk directly. When prediction engines are confident until they're wrong, how do we design them and ourselves to miss less, confess faster, and keep watch anyway? AI is confident until it's wrong. Neural networks are superb at recognizing the familiar. Feed them years of asteroid telemetry positions, light curves, radar shapes, and they learn the grammar of ordinary motion. But familiarity is a leash. When the sky behaves like the training data, the black box sings. When a small force changes sign after a close pass, when dust lifts for a week, when spin wobbles by a sliver, when the distribution shifts, the same model smiles and says normal, because it has never been taught how new looks. Out of distribution is the quiet villain here. A network trained on main belt asteroids or well-behaved near-Earth visitors may treat a resurfaced, half-tumbling rubble pile like a typo to be smoothed away. It will interpolate across surprise, presenting a curve that flatters our priors. Calibration plots still look tidy, loss curves still descend. We believe that because the machine sounds calm. Opaque confidence is not knowledge, it's an aesthetic. There are cures, but they require humility. First, make the machine confess its uncertainty, not just a softmax score, but calibrated intervals. Conformal prediction bands that widen when features drift, Bayesian approximations that carry epistemic ignorance alongside aleatory noise. If the model cannot say "I don't know," it is not a partner, it is a liability. Second, ensembles and residuals. Pair the black box with physics you trust, an n-body baseline plus thermal drift terms, then let a network learn only the residual it can actually improve. If the residual spikes after 2029, you don't get a false comfort, you get a flag that the world changed. Force the learning to live in the difference, not the whole. Third, adversarial validation. Before you bless a pipeline, try to trick it. Mix in synthetic light curves with tiny comb. Inject period shifts at the 1% level. Simulate radar echoes with shape details the model hasn't seen. If the system dutifully cleans those novelties back into normal, it isn't ready. Build a curriculum that teaches the model to preserve anomaly, not erase it. Fourth, interpretability. Saliency maps, Shapley values, feature ablations tools that let you see what the network thought mattered. If a spin change allegedly drove a forecast shift, the internal attention should tilt toward timing features, not stray streaks in the photometry. If it doesn't, the answer is theatre. Data governance matters as much as architecture. Version every dataset. Hash the raw frames. Keep a ledger of calibrations, weather logs, satellite glints, and power sags, so that when a prediction drifts, you can trace the ancestry of the error. Models are only as honest as their provenance. And then, the human loop, not as a romantic flourish, but as design. Nightly triage, where a rotation specialist, a radar lead, and a thermal analyst review outliers before they update public risk tables. Playbooks that freeze model weights during storm nights until cross-site checks clear. Dashboards that surface "I don't know" cases to people empowered to say, well, wait for Chile, or rerun with last month's gain map, or flag to mission ops, because missions are where belief becomes hardware. If Ramses and Osiris Apex, or their eventual siblings, are our weigh-in and close-look insurance, their design should expect the machine to miss sometimes. Trajectory margins that tolerate late updates. Instrument suites that can pivot if a faint coma appears, switch to high-phase imaging. If spin flips sign, retune cadence. Communication protocols that separate model suggests from measurement shows. Quiet suspicion is a healthy posture, not paranoia discipline. We let the models help with cadence, scheduling, and triage. We refuse them the authority to close the book. We measure, compare, and only then update the sentences the public hears. Confidence becomes a tool checked in and out, not a credential worn to the podium. Hold the motifs to steady the hand. Light is still the arbiter. Photons, echoes, heat maps, the machine must answer to. Silence is the pause after a surprising output, the breath before action, while a second team replicates the result. Memory is the audit trail that lets us unwind a wrong turn without blame. Breath is pacing. Models updated on seasons, not moods. Policies that wait for convergence, not virality. AI will be part of the watch we keep. It will sort nights, spot trends, and sometimes see patterns earlier than we can. But it will also smooth away a hinge, average out a warning, declare certainty where the universe has left the sentence open. Our job is to design a system that treats those misses as early lessons, not late regrets. Next, we turn suspicion into assignment. The vigil itself funding the eyes, launching the weigh-ins, and holding the window open while the math catches up. No deflection needed yet, but the data window closes soon. This is the season for steady hands. If the flyby is our weighing machine, the missions are our stethoscopes. One is already real. A proven spacecraft retasked to meet a rock with new questions. Another is the kind of concept we assemble when prudence refuses to wait for drama. Together they define a posture. Don't shove study. Don't promise measure. Don't blink. The first is the workhorse we know. An asteroid sample veteran turned escort, headed to Apophis with instruments that have already earned their keep. Cameras that can see texture, not just outline. Thermal eyes that read the timing of heat like a pulse. A laser altimeter to drape geometry with precision, frame by frame. Radio science to weigh by gravity's whisper. If the surface is a quilt of dust and boulders, this craft can map the seams. If the spin shifts after Earth's tide has its brief say, this craft can catch the new rhythm. Plans even include stirring the skin, gentle thruster plumes near the surface to watch how grains loft and settle. A low-risk way to reveal cohesion and grain size without fireworks. The second is a placeholder with a purpose. Call it Ramses, because names help us think. Not a battering ram, not a last-minute rescue, but a lean, deadline-driven observer you can build quickly and aim precisely. A small bus, a fast cruiser, or a pair of cooperative scouts. One could ride a tight flyby in 2029, carrying a polarimeter, a compact thermal imager, and a dust counter to catch any faint coma the big mission might miss at a different local time. The other, if funded, could return years later when resurfacing and the soft thermal engine has had time to write its edits. 2 snapshots, spaced in time, turn a guess about drift into evidence. What's riding on them? Everything we just admitted, we don't know. Mass with error bars, small enough to move keyholes off the table rather than across it. Rotation state pinned tightly enough that a half-degree shift has to introduce itself. Thermal inertia is mapped in patches, not averages, with roughness quantified instead of assumed. Albedo and size are measured together, so density doesn't lie. Regolith depth and cohesion are bounded by how plumes behave and how shadows change. Upper limits on volatile activity that are honest, even when they're nothing, because nothing, measured, is still a page in the log. Deadlines are not a mood, they're orbital mechanics. Miss a launch window and geometry punishes you with longer flights, harsher trajectories, or a blank try again later. The calendar won't forgive. Miss instrument readiness, and the cleanest pass in a century becomes a pretty light show with fewer answers than it deserved. Miss funding cycles, and an entire year of work vanishes into paperwork, while the sky continues on schedule. Calm urgency means writing the dates on the wall and building as if they're real, because they are. Coordination lifts the ceiling. The escort craft can live low and slow, reading texture and heat at close range. The quick scout can grab high phase angles and weird local times a single orbiter can't. Ground campaigns can tune cadence to fill gaps. Occultations to fix shape edges. Radar to keep spin honest. Photometry to watch for the faint fog that a single camera geometry might miss. Redundancy is not waste. It is how confidence stops being a press release and becomes a number with a provenance. And candid communication buys time. No deflection needed yet is not a hedge. It's a promise to keep watching. It says, we will not spend the public's fear. We will spend our nights. We will brief on what we see, what we don't, and when to expect the next answer. We will separate model suggests from measurement shows, and we will let I don't know be a milestone we pass, not a hole we fall into. That posture is how missions survive the news cycle long enough to matter. Hold the motifs while the to-do lists multiply. Light, gathered from orbit and ground, is our discipline not just illumination, but information. Silence is our design principle systems that keep working when storms talk and streaks intrude. Memory is our archive before, after, maps that make 1% edits legible to policy. Breath is our cadence campaigns that pace themselves across quarters and years, because April will not be the end, only the hinge. If we do this well, the vigil feels almost boring from the outside. Schedules met, calibrations repeated, updates that sound like as expected until the day they sound like now we know. But boredom is the scaffolding of safety. The breathtaking parts, the sky glowing with a near-Earth pass, the first close images of a surface that has never met a camera are the reward, not the plan. And if we fumble, the cost is not spectacular. It's thicker error bars that drift back across thin corridors we were proud to erase. It's a public forced to relearn that no threat means keep measuring, not go to sleep. It's a story about us, told by a stone, in a language we could read if we stayed in class. So we keep watch. We fund the eyes. We put the small craft on rails that hit their marks. We admit the nights we lose and overbook the ones we can save. We remember that vigilance is not fear, it's attention with a calendar. From here, the turn is simple and large. We've built the case for care. Now, we have to say why we choose it, even when probability invites complacency. Hope is not a plan, but neither is dread. What we keep in the dark is not the sky, it's humility and the quiet courage to prepare for truths we do not control. Optimism without measurement is just luck. It feels gentle to say it will be fine. It feels humane to soothe. But comfort that refuses numbers is not kindness. It is abdication. Uncertainty has math. Ignoring it does not make you brave. It makes the problem someone else's. Preparation is not panic. It is the quiet insistence that outcomes bend toward effort. Weigh the rock, pin the spin, map the heat, audit the clocks, rehearse the ugly nights when storms talk and satellites shed light we didn't ask for. Each action shrinks the future's wiggle room. Each update trades rumor for range. This is the moral core of planetary stewardship. Do the small things on time so the big things never have to be done. We owe the public plain speech. Low probability is not code for don't look again. It means look well at the cadence the risk deserves. Say what we know, admit what we don't, put dates on the wall and show up for them. Confidence should arrive with a receipt method, data, error bars, so trust lands on wood, not smoke. Preparedness is also psychological. The hardest part of vigilance is boredom. Quiet nights tempt shortcuts. 1,000 clean frames whisper that the 1,001st will be the same. That's where teams fail, not for lack of talent, but for lack of ritual. So, we make rituals. 2-person sign-offs on timing. Control targets every session. Posted checklists that survive turnover and election cycles. We design our attention so fatigue can't steal it. There is dignity in refusing melodrama. We do not fear to motivate. We clarify to empower. We do not sell miracle missions. We fund plain, capable craft that keep their promise. We do not pretend certainty. We practice transparency. If a number won't settle, we publish the interval and the plan to narrow it. If a night fails, we say why and shift the schedule so the whole campaign doesn't sag. Hold the 4 motifs as a creed. Light is not spectacle. It is information gathered on purpose. Silence is not neglect. It is the space where repeated measurements become confidence. Memory is not nostalgia. It is the ledger that lets 1% edits be believed. Breath is not delayed. It is pacing that keeps April from being a cliff and makes it a hinge. Hope still has a place, but not as policy. Hope belongs in the human reasons to bother children at a window, a first telescope, the simple joy of getting a hard thing right together. Strategy is what keeps that hope honest. Strategy is why, years from now, a returned corridor will be a footnote and not a headline. Why a thin keyhole will remain a curiosity and not a date. We choose preparation because it is the only form of optimism that keeps its promises. From here, the voice softens. Numbers step back, not because they're finished, but because they have done their work for tonight. We've made our case for care. What remains is a smaller sentence, said quietly, to carry with us when the sky brightens and the object slides on, a reminder of what watching means and why we keep doing it. We're not watching out of fear. We're watching because we know what not watching once cost us. There is a kind of courage that looks like attention. It doesn't stamp its foot or raise its voice. It stands on a cold night with a notebook and lets the sky speak. It learns the grammar of motion, the patience of drift, the way a dot becomes a story when you refuse to blink. That is the courage we practice now. The scale dwarfs us, and yet the work is small. Exposure after exposure, echo after echo, timings snug to the second. We carry lanterns, not searchlights. Still, lanterns strung across continents become a line of day in the dark. And in that line, the universe writes legibly if we hold still long enough to read. Humility is the posture that makes reading possible. We walk back every boast. We let better numbers overrule our favorite sentences. We treat models as ladders, not ceilings. When the universe laughs, we laugh with it, then rewrite. It isn't a defeat to be corrected by a photon. It's the privilege of belonging to a world where truth is patient enough to be found. Vigilance is the craft that turns humility into safety. We keep clocks honest when the sun misbehaves. We subtract our streaks from our stars. We harden the weak links before they snap. We build missions quiet enough to hear dust move and brave enough to admit when it didn't. We publish the calm page as faithfully as the dramatic one. So much of safety is just the habit of showing up. Cosmic scale asks for both. Heads bowed, eyes open. The distances are cruel, the force is indifferent, the timeline's long enough to make our calendars look like confetti, and yet here we are, specks drawing maps on a moving stone, learning to hear the breath of heat leaving another stone, and letting that whisper steer our choices. It would be easy to romanticize this, better to name it. Responsibility. Light, silence, memory, breath, let them close the circle. Light, what we gather, not for spectacle, but for proof. Silence, the space where 1,000 ordinary nights assemble into one honest sentence. Memory, the ledger of before and after, written in margins so narrow only the patient can see them. Breath, the cadence that keeps the vigil. Human inhale the surprise, exhale the revision, again and again, without rancor, without hurry. When the flyby comes, it will be beautiful. A bright bead sliding through our radio towers and camera domes, the planet briefly a mirror for a visitor that does not care it is being seen. Crowds will look up, children will learn a new name. Somewhere, a graduate student will cry in a control room and pretend it's just the air. We will collect our numbers, compare them to the numbers from before, and accept what they say. Then we will keep going, because vigilance has no final act, only intermissions. There will be other objects, other nights, other thin corridors to map and step around. The echo of this moment will live in the habits we kept, the instruments we maintained, the playbooks we wrote and handed to people not yet born. A civilization can be measured by what it chooses to notice. We can choose to notice well. The sky never promised comfort. It promised truth to those who stayed long enough to hear it. That is our bargain with the dark. The god of chaos is coming. We've done the math. Now we wait for the truth.